Algebra 1, Lesson 51, Part A is graphs of linear equations. And if you recall, we just recently were talking about coordinates and ordered pairs, and so it's still using those things for this. So a little bit of information to fill in, and we're just going to go ahead and do some graphing. If we use a rectangular coordinate system to graph the ordered pairs, remember we chose some x's, found out what y had to equal. When we graph those ordered pairs that satisfy the first degree polynomial equation in two variables, the graph will always be a line, a straight line. In math, we always mean a straight line when we say a line, so I'm just writing line. So we call it a linear equation because it makes a line. Okay, so here are some examples of linear equations in two variables. There's one, first degree, the exponents are only 1, and two variables. That, when we graph it, would make a straight line. Y equals 7x minus 1, that would be another one. X equals 4. That would be another one. Now on this one you only see an x and not a y, so there's something a little bit special about that one, but technically it still is. The y would just be the 0 power. It still will make a line. It is still a linear equation. It's not just going to be a point. It'll be a line. Okay, so how to graph a linear equation in two variables. What we're going to do is what we did in that last lesson, choose some values for x and find out what y equals. It'll give us ordered pairs, and then we graph them. So choose values for x. We're going to pick at least 3 each time. That way you need at least 3 to make sure. 2 points determine the line, but if you do a calculation error, you may get an incorrect line. If you do a third point, and hopefully only make one mistake, if any, if you make one mistake, you'll get a zigzag, and then you know it's wrong, and then you go back and fix it. You wouldn't leave it like that. So we choose values for x, put them in, substitute them in, and put evaluate to find y. And then we graph the points. Okay, so we're going to make a chart to keep our information organized. And what I'm going to do is make columns for the x's that I choose. And then I'm writing, by the way, whenever we're doing these, we want y to be by itself. And so far, they're like that for you. So y equals, what does y equal? 2x minus 1. I'm going to evaluate that for my values of x. Write down what that actually equals. And then I'm going to write the coordinates of our points over here. You'll be able to make your charts have fewer columns later when you get used to this, but for now it's good to keep all of the stuff organized. Okay, and then looking at the Cartesian coordinate system that you were given, this goes from -5 to 5, so our x's are restricted to that. And it's usually easier for us to work with 0 or positive numbers, so if I can avoid negatives, I'd probably do that, so I'm less likely to make a calculation error. I think I'm just going to start with 0, and then I'm going to keep going up 1 for my x's. If you have a pattern to your x's, you should also see a pattern to your y's, and that'll be helpful too to make sure you know you got it right. So now I'm evaluating, so I put 0 in place of the x, and then for this one I'll have to put 1 in place of the x, and then 2. And then in the y column, we actually figure these out, do the order of operations. 2 times 0 is 0, minus 1 is -1. 2 times 1 is 2, minus 1 is +1. And then here we have 4 minus 1, which is 3. And I mentioned having a pattern as long as you have a pattern to your x's. Okay, my x's go up 1 each time. Looks like my y's are going up 2 each time. So I see a pattern, and that's a very good sign that I'm getting this right. And then I'm just going to rewrite my x and my y as an ordered pair, and then we're going to graph those ordered pairs on the coordinate system. Okay, so 0, -1 will be right here. 1, 1 is here. And then 2, 1, 2, 3 is right here. And then I take my straight edge and connect those dots. And you need to connect them, don't just stop at your last point that you graphed. Go the whole way to the edge of this, like that. Every single point on this line is a solution to that equation. If we put the coordinates of any of the points that I graphed, not just where the dots are, it'll make that equation true. For instance, I can see that -1, -3 is a point on my line. So if I put -1 in place of the x and -3 in place of the y in here, this equation should come out true. Because every point on this line is a solution to that equation. Okay, now in the next one we have a fraction as a coefficient for our x. And when that happens, you want to use a little strategy to choose your values for x so you're not having to guess where to graph fractions. We're trying to avoid those. Let me write -1/2 x plus 2 right there. And my y. And xy. 1, 2, 3. All right. Now, when I put a number in place of x, I would like to end up with an integer here, so I don't have to, like I said, guess where to graph the fractions. So I need something that will divide evenly by 2, which means I'm picking even numbers for my x's. So I'm going to go 0, 2, 4. There's still a pattern to my x's, so I can look for a pattern in my y's. And right now I'm just rewriting that expression, putting my values for x in. Okay, 0, 2, and 4, where the x was. And then we simplify each of these expressions using the order of operations. 0 times -1/2 is 0. Add 2 to that, you get 2. Okay, so half of 2 is 1, but it's negative. So -1 plus 2 is a positive 1. Half of 4 is 2, but again, it's negative. -2 plus a positive 2 is 0. And I have a pattern. It keeps going down 1 each time. So again, a good sign. Now I'm writing my ordered pairs so I don't get lost in my chart when I'm graphing. Okay, 0, 2, 2, 1, 4, 0. Graph those points. 0, 2 is right there. 2, 1, and 4, 0. And they line up like I thought they would because of finding that pattern. And then I take my straight edge and connect the dots the whole way across there. And again, if I graph carefully, every single point on that line will be a solution to that equation. And I was off a little bit. I had this held awkwardly so that you could see it, but I am off a little bit. I think it should have gone through right there. That should be another point on my line. But that's how you graph. Okay, there's more. Okay, so on the back we have just y equals -x. This one's shorter. And so I'm going to pick some x's. And then we're going to do the opposite of that for our y. And since that's so very short, whatever I write here is equal to my y. There's nothing really to evaluate. So I'm going to spare myself that column. And then just do the xy here. Okay, and we can pick anything that'll fit on this graph. Again, it goes from -5 to +5, and we didn't do any negatives yet. Let's do -2, 0 and positive 2. They wouldn't have to be even. We're not dividing it by 2 or anything, but then we get some of each sign. Okay, so negative 2. This is the opposite of that. The opposite of negative 2 is positive 2. The opposite of 0 is just 0. And the opposite of 2 is negative 2. So we're graphing negative 2, 2, 0, 0, which is the origin, and 2, negative 2. Okay, so negative 2, 2 would be this one, in the origin, and then 2, negative 2 is down here, and then you connect the dots. I'm going to go ahead and move this time. Try to get a better line. There, that should be pretty good. Okay, basically this one should go corner to corner, just because of where the points are. Okay, and again, make sure you get the whole way across, not just where you put the points. All right, now on to part B. It is still graphing lines, but these are special. And a quick tip for these, when you are graphing these, basically your line will passes through the axis that is named in the equation. Okay, at the number in the equation. You get vertical or horizontal lines for these. That's the name of this section. So this one, I see an X. So that would be the axis named. It's going to go through the X-axis at this number. Because what this is saying is, this says X is 2. X is always 2. No matter what Y is, X is always 2 on this line. I mean negative 2, sorry. X is always negative 2 on this particular line. So the coordinates of all your points you graph are going to be negative 2 some number. Negative 2 for the X and then whatever number for the Y. So, okay, negative 2 on the X-axis, right there. Negative 2, 0, that fits this. Negative 2, 1 fits this. Negative 2, 2 fits this. As long as X is always equal to negative 2, it satisfies that equation. So this is making a vertical line. Right here. Goes through the X-axis at negative, whoops, my ruler moved, at negative 2. Okay, that's all there is to that. All right, next example. Y equals some number. So that means Y is always 4 for this one. And so our coordinates will be some number, comma, 4, because Y always has to be 4. So, based on what I told you earlier, our line is going through the Y-axis at 4. So here's the Y-axis, 1, 2, 3, 4. Okay, 0, 4 satisfies that. 1, 4, negative 1, 4, 2, 4. All the way across there, we're getting a horizontal line when it's Y equals some number. Okay, so we'll graph that right there. And that's all there is to that example. Now, on the last one, we have 2 different lines we're supposed to graph on the same coordinate system. Okay, so no problem, we can do that. We're going to do them separately, and I'm going to letter these. There's an A and a B, so line A and line B. Often in the problem sets, when you're having to graph 2 of them on one plane, they'll have them numbered again. They'll have them lettered like that for you. So you should label them on your problem set. So Y equals 2x, we'll do a little table for that. Pick some values for x. Anytime you have a Y and an x in your equation, it's good to do that. So there, and then Y, and then xy, 1, 2, 3. And we can pick whatever x's we want because we're not multiplying by a fraction. The only thing is I'm looking ahead, and if I pick 3 for my x and I double it, I'm getting 6, and that takes me off the graph. Only choose things. If you happen to pick one that doesn't fit on your graph, don't start adding lines because it's not going to be the scale probably. Just pick a different x. Okay, so let's do, because I know I don't want to go up to 3, let's just do 2, 1, and 0. They'll be okay. I was going in ascending order. So 2 times 0, 2 times 1, 2 times 2. So here y is equal to 0, 2, and 4. So the coordinates are 0, 0. That's the origin again. 1, 2, and 2, 4. So graph 0, 0, 1, 2, and 2, 4. Connect those dots the whole way across. Alright, and there is my line. I'm off just a bit. My dots were so big that I didn't quite get where I needed to be. It's pretty close. Okay, now that was line A, so I'm going to put an A up here at one of the ends of it. Y equals 2. This is one of those we don't really need a chart for, just y will always be 2. So we'll find 2 on the y-axis. And y has to always be 2, so it's going to be a horizontal line there. My paper again. Y equals 2. You see those lines intersect. Right there. Label this. That was line B. I'll put that over here, I guess. And we are done with that example. I believe we are done with these notes. Have fun graphing.